While talking about space tourism, let's take a look at the state of space around the Earth and, in particular, in the case of space debris. Currently, 8,800 tons of active or dead satellites, rocket debris, and satellite debris orbit above our heads. Launched at 28,000 kilometers per hour, a 1 centimeter fragment can destroy a satellite. These space debris regularly enter the atmosphere. Some survive the fall and pose a danger to Earthlings. Urgent action is needed to limit their proliferation, warn space agencies such as the National Center for Space Studies, CNES. What are the risks of space debris in space and on Earth? How can we count them? How to limit their proliferation and clean up the space? Christoph Bonnel, researcher in the CNES Launch Department and chairman of the Space Debris Commission of the International Academy of Astronautics. How do you detect and count space debris? There are different detection technologies, adapted to different altitudes. Radar, like road radars, they send a sequence of electromagnetic waves that are reflected by the object and return to the radar. By measuring how long these waves take to make the round trip, we know their location. The advantages of radars are that they work in all weather conditions and can locate an object at any speed. One of the disadvantages is that its performance decreases dramatically with distance. Therefore, they are only suitable for low orbits. Another disadvantage of radar is that not all surfaces reflect waves as effectively. It is often said that radars can detect objects larger than 10 centimeters. About 30 radars around the world have made it possible to establish a catalog of 26,000 space debris. Telescopes act as cameras and detect objects that reflect sunlight. Telescopes work well for high-altitude objects in geostationary orbit, 36,000 kilometers. On the other hand, its performance in detecting an object depends largely on its ability to reflect light. 4 French telescopes cover 3/4 of the geostationary orbit. There are about 30 telescopes in the world. Laser is a new technology that allows tracking, i.e. tracking, and calculating the orbit of a known object with great precision. The disadvantage of lasers on Earth is that the atmosphere darkens them. We are currently working on lasers in orbit that would not have this problem. What are the risks in space and on Earth? The risk to the people of Earth. Any object, up to an altitude of 2,000 kilometers, is subject to the effects of the residual atmosphere and slows down. Space mechanics shows that when an object stops, it descends. Then all the debris is drawn in an accelerated downward spiral. One day they will return to Earth. At an altitude of 800 kilometers, it could take 2 centuries. When these objects enter the atmosphere, they begin to fragment. Even objects melt when they are dropped, they evaporate. The exception to what does not vaporize is titanium or carbon. It is estimated that 10 to 30% of the mass of an orbiting object survives its re-entry into the atmosphere. Then some objects reach the surface of the Earth. Only 3% are densely populated. So far, there have been 25,000 rumors about orbital objects and no casualties. Like a sword of Damocles, we have 8,800 tons above us that will fall. We don't know where, we don't know when. For example, a 50 kilograms titanium tank was recovered from a Ugandan woman's garden. So far it has been good luck, but in the future it is essential to control it. Risk of collision in orbit. A 2 or 3 millimeters object can destroy a satellite. A millimeter object has the energy of a bowling ball launched at 100 kilometers/h. If it lands on the onboard computer, the mission is over. From 1 centimeter, the satellite is dead. From 5 to 10 centimeters, the satellite not only died, but shrank. It fragmented into hundreds of debris, which in turn is a danger. For example, the collision between the 2 satellites Iridium-33 and Cosmos 2251 generated 4,000 large debris. This is called Kessler syndrome, developed by Donald Kessler in 1978. This theory shows that out of a certain volume of debris in space, collisions between debris are so frequent that the number of debris increases exponentially. So the main problems with collisions are that debris kills active satellites. Risk for astronauts. Astronauts are relatively small, at an altitude of 420 kilometers. There is still enough residual atmosphere to clean the orbits. There are fewer risks, but the consequences of a collision would be catastrophic. We calculate that the probability of losing an astronaut is 1 in 60 per space mission. Now this risk is multiplied by a factor of 10. Astronomers upset. Astronomers looking at the sky are hindered by satellites or debris that reflect sunlight. For example, the Vera C. Rubin Observatory telescope is very sensitive and has a wide field of view. The goal is to conduct an investigation of the universe. The telescope detects everything in front of it, including tens of thousands of orbital objects. How to limit the proliferation of space debris in the future? It is imperative to limit the proliferation of new debris. At international level, the Interinstitutional Coordination of Waste, DCI, sets out the recommendations. This agency that we named brings together the 13 major space agencies capable of generating space debris. They worked on the general international rules that emerged in 2002. The United Nations Space Committee adopted these rules in a resolution in 2007. The International Organization for Standardization, ISO, finally accepted these recommendations. These are: prohibition of deliberate generation of waste, orbital explosion prevention, prohibition of stay longer than 25 years, avoid collisions as much as possible, protecting populations on land. At the state level, several countries have set national standards. There is no binding international treaty to regulate the proliferation of space debris. This binding international treaty, not even through the UN, is very difficult to reach a consensus with countries like China or Russia. Moreover, a kind of space police should be created and no country would agree to submit to these police officers. At the moment, everything that is mandatory is done at national level. How to empty the space? Should we create the garbage collector profession? If we do not develop this profession, we are doomed. In addition to limiting the proliferation of debris, the space must be cleaned. Area of 760 to 820 kilometers, there is almost nothing but waste, nothing can be thrown into it. To avoid collisions, 10 large pieces of debris per year should be removed. For this, we send using different techniques: robotic arm, nets, harpoons, blowing with electric propellers or attraction with electrostatic force. This garbage collection activity would raise many questions. First of all, legal. Space regulations stipulate that we do not have the right to touch debris that is not ours. Each object released depends on the launch states of the different countries that produced it, assembled it, released it. If we desorb a fragment that does not belong to us and collide with a satellite, who will be responsible? Another problem, that of costs. The desorption of a large amount of waste is very expensive. For example, the startup ClearSpace, which is preparing its first mission to desorb 120 kilograms of debris, estimated the project at $80 million. Who will pay for the cleaning of the space? There is a promising solution to overcome this problem that the European Space Agency, ESA, is working on. It would be a matter of combining the cleaning activity with another activity. IOS, in-service orbiting, satellites are like space recovery vans, they fill, repair and move satellites. The absorption mission becomes marginal and therefore much less expensive. To solve the legal problem, one solution would be for the IOS satellite to have the launch status of the main space agencies. Therefore, it would have allowed you to desorb all the debris. Underscore 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 underscore. There are over 16,000 man-made space objects listed out of almost 1,300 that constitute only operational satellites. Identification of risks associated with space debris. Space debris comes from several sources and can be classified into 4 categories: Non-operational satellites are satellites that have reached the contractual term and have suffered a premature failure with the consequent loss of control. Disused launch bodies, which are the upper stages of the launchers used to inject the payload into the search orbit and which remain in orbit after the completion of the mission. Launchers are designed to enter the atmosphere over oceans or uninhabited areas. Mission refers to objects and materials, fastening systems for solar panels, etc. 3 accidents have accidentally caused cosmic debris in the last 50 years. The Cosmos 954 satellite crashed into Canadian territory in 1978. The Columbia spacecraft crashed on its return from the mission in 2003 and collided in 2009 at 770 kilometers altitude. 2 satellites from different countries, Iridium 33 and Cosmos 2251. 2007 China, which launched a rocket at its old satellite. The United States did the same in 2008. To date, only one human has been hit on January 22, 1997 by approximately 6 inches of space debris in Tulsa, Oklahoma while walking in a park. Today, the risk of a spacecraft colliding with an object larger than 1 centimeter, which could cause the spacecraft to be completely destroyed and generate other debris, is estimated as an event every 3 to 5 years. Elsewhere, there are about 750,000 dangerous objects in space. With the proliferation of satellite constellation projects and the emergence of new launchers, the launch of satellites planned for the next decade and committed to changing current practices, the number of debris will increase to even greater proportions. Insurance. The risk associated with space debris is considered relatively low, but exposure is now being reassessed. General insurance insures life in orbit. General insurance distinguishes between 3 types of risk: ground risk, launch risk, and orbit life risk. Satellite damage insurance is usually a coverage basis. Damage caused by malfunctions is understood as any false power that has consequences for the operation of the satellite. To date, space damage insurance does not provide for a specific exclusion of damage caused by satellite space debris. This type of insurance will be extended to cover any accidental damage or loss of the insured satellite due to any space debris, both in the most likely phase of the launch phase and during the life phase in orbit.